Hello guys, so in the last video I have discussed about the convolutional layers and pooling layers. Now I will discuss further about the convolutional layer. So I have already discussed about the grayscale image, which is a 2D image, and I have discussed about the RGB image, which has three channels: red channel, green channel and blue channel. So it is a 3D matrix kind of thing. So first if we begin with the 2D image, which I have already discussed, if you can see in the left hand side you have a 2D matrix, that is the input image, and then what you are doing is convolution using a filter, which you can see on the right hand side, this one. So this is a filter which has the values, you can see 111, 000 and 111, like this. Now if the convolution has to happen in the left image, which is this one, what you do is, and we are taking a stride as 1, and we are not padding the input image with any 0 values around this image. So padding is 0. So I will explain about the padding in the next video, but let's suppose the stride is 1, that is the movement of the filter image. This one is one step at a time. So in the first step it will take these all values and multiply correspondingly. That means 5, 5, 5, 5, 5, 5, and you have to convolve with this filter, which is 1, 1, 1, 0, 0, 0, 1, 1, 1. So this is not the matrix multiplication, rather it is element to element multiplication. So if you multiply this 5, you will multiply with this one, corresponding values. If you multiply this 5, you will multiply with this 0, and if you multiply this one, you will multiply with this one. So it will be like this: 5 into 1 plus 5 into 0 plus 5 into 1. This is the first row. This one with corresponding values in this one. Then you add it again here, plus 5 into 1 plus 5 into 0 plus 5 into 1. So sorry, this is minus 1. Here this is minus 1. 5 into minus 1, and then again 5 into 1 plus 5 into 0 plus 5 into minus 1. So this gives net value as 0. So this is the value which you get here, and this is the output value. Now if you move this filter from here with one step ahead, you will take these values. So if you take these values and then multiply again, so this is, instead of, if you see, it will be like this: 5, 5, 5, 5, 5, 5, and this is 0, 0, 0. This is the thing, and you have to convolve with the filter, which is 1, 1, 1, 0, 0, 0, minus 1, minus 1, minus 1. Same was here, like this: minus 1, minus 1, minus 1. So if you do again, you will multiply and add them, you will get the net value as 50, which is shown here. So you started with 6 by 6 input matrix, and you had a filter matrix which is 3 by 3. You get output image is 4 by 4. So this you can write as like 6 minus 3 plus 1, 6 minus 3 plus 1. This is the dimensions, which is the 4 by 4. So this is the formula, you can say. So 6 is the number of rows and 6 is also the number of columns here, and 3 is the size of the filter matrix. Now if we start with this RGB images, if you see here, now you are starting with a convolution on the RGB image. Earlier you had only 2D matrix, but now you have an image in 3D format, which is having 3 layers, and each layer is a 2D matrix. So basically there will be 3 2D matrix, or you can say it is a 3-dimensional matrix. You have length, you have breadth, you have height. So you can say that the number of, so you have height, you have breadth, and you have the number of channels, NC. So this is 6 by 6, this is 6 by 6 by 3, and you have filter here. Now the filter, instead of having only one filter of 2D matrix, you will have 3, because the number of channels are 3. So you have a 3 by 3, suppose you have 3 by 3 dimensional matrix, and since the number of channels are 3, so you will have 3 layers. So basically it is 3 by 3 by 3. So it is a 3D matrix of 27 elements basically. So now instead of rastering a scan over the 2D matrix, you will scan over the whole volume. So if you take this, matrix, this 3D matrix, and bring it over the this 3D matrix, you see here on the left hand side, if you place it over the whole volume, on the left hand side, left corner, you have these 9 values in the first layer. Similarly, you have 9 values in the second layer, and similarly you have 9 values in the third layer. Basically there are 27 elements in the image matrix. Similarly, you have 27 elements in the input filter matrix. So you will, instead of convolving with 2D to 2D, now you're convolving over all these 27 elements. You will multiply one by one, and all the multiplications, 27 elements, will be added up together to get one value. So it will be something like this. So if you see here, you have filter, it is 3 by 3 filter size, and the number of channels is 3, stride is 1. You're moving this whole filter volume one step ahead at a time, and the padding is 0. You're not putting any 0 values in the input image. So now you have all these 27 elements in the filter. You convolve with the input volume, and you get one value, which is 2. Here you can see, and then you move ahead and you get the corresponding values in further. So this 2 is coming with the multiplication of all these 27 corresponding elements of filter with the corresponding elements of the input matrix. So basically you start with 6 by 6 by 3, and you convolve with filter of 3 by 3, and number of channels is 3, and you will get 4 by 4 matrix of third dimension will be 1, because across the depth you multiply all the elements and you get only one value. So since if you take this filter and put it at the left corner of this input image, all these 27 elements convolve into one value, which is 2. Again, if you move ahead in the input image, you will again get one value, which will be placed just next to the here, and then you get this value and then this value. So if you take the second convolution for the stride, then you will begin with this. You will go till here and you will take all these values. This is stride 1. So basically this is, you have moved ahead with one step. So in the next video I will talk about how you can use multiple filters if you have more than one filter. So how you can do that. Thank you.